Let's try to investigate horizontal transformation, and in this video we'll talk about reflection. The graph of f of x equals to square root of x is reflected on y-axis. So this is f of x and it is reflected on y-axis. Write the equation of transformed function g of x. How are the points in two graphs related? So as you can see, the reflection is on y-axis. So whenever there is a reflection on y-axis, we see a shift which is kind of horizontal in nature. Do you see that? So it is horizontally reflected on y-axis. So we can write the function g of x in terms of f of x, which is square root of x, as minus of square root of x. So that is the way to write reflection on y-axis. So minus here indicates it is inside the function, square root function. Whenever we have any change inside the function, it affects horizontally. Remember that. So inside function, the result is results into horizontal transformation. That is kind of important to understand. Correct? So inside function, when I say inside, what I'm trying to say, outside will be if I add something here or multiply something there. That becomes outside. And this is square root, and whatever is inside square root, this is what we're talking about, right? So inside the function results into horizontal transformation. It could be stretch, compression, reflection or translation, but horizontal. The key term is horizontal in nature. Now this time it is only reflection. So reflection is when negative x, right? You could see it like this also. If you have square root of minus x, then what should be the domain of this function? Minus x should be greater than equal to 0. Otherwise we'll get something negative and we can't find square root of negative number, right? It won't be real, it will be imaginary. So if we solve this equation, so the domain of our function is minus x is greater than equal to 0. That means x is less than equal to 0. When you multiply by minus on both sides, you have to change the sign. So you can see domain for this function is that x is less than equal to 0. That is important. And how about the range? Range for this function is that y is greater than equal to 0. So the range remains same. But what is really affected is the domain. So what really happens here? If you consider the points, the x points get multiplied by -1 and they change like that. Do you see that? So that is the kind of transformation which is taking place, right? So that leads to the second part of the question. So the first part we just done. Write the equation of transformed function g of x. So the equation is right there. G of x is equals to minus x square root. Since there is a horizontal reflection along the y-axis, right? So inside function changes, and we kind of checked it also. It works, right? So the domain of this function is x is less than equal to 0. Now let's see how the points get transformed. Now if you consider the points of original function, what are the critical points? The critical points are it starts at 0, right? So origin. So we'll write the points of this function and see how do they get transformed, right? So the points here are starting off with, let me use a different ink here. So we say the points here are, we are considering the function f of x first, right? Let's write f of x here. So we have a function f of x and the points on f of x are 0, 0. And then square root of 1 is 1, so that's a good point to take. So 1, 1. Square root of 4 is 2, right? So that is square root of 4, which gives us 2. So we get square root of 4 is 2, so it is 4 and 2. Now if you compare these points with g of x, so how do they compare? So you'll notice that 0, 0 remains at the same position, right? So the points are 0, 0 is same, so we have 0, 0 here. The next point actually gets reflected. So the y value remains same, but the x value becomes -1. and the next point also gets reflected, and we get here. So it gets reflected as if this was a mirror, right? So the point is at -4. So the points are, you multiply these by a factor of -1, right? So you get -1, 1, and you get -4, 2. So these becomes the transform points for g of x. So in general, what you can say is that, now let me write a general statement, that if the function is f of x and it gets transformed so that you get a new function which is f of minus x, right? So in that case, the transformation will be, if we have points x and y on function f of x, then they get transformed so that all the x points get multiplied by -1 and y points remain same. So that is what happens, right? That is the transformation. As you can see from here, so the domain also gets multiplied by -1 and the range remains same. Do you see that? So the domain here was greater than 0. When you multiply that by -1, it becomes less than equal to 0, right? It was greater than equal to 0. As far as range is concerned, it remains same in both. Do you see that? Range remains same in both. So original function f of x had domain which was equals to x greater than equals to 0, and you had range y saying y is greater than equal to 0. So if you compare with g of x, the domain and range is same, but domain has flipped horizontally towards the left. That is how it is, right? So I hope you understand the effect of horizontal reflection. It really affects the x values. They get multiplied by -1, and y values remain exactly the same. And as far as a graph is concerned, it looks as if there is a mirror along the y-axis which has reflected everything. And that is what horizontal reflection is. Correct? I hope you understand. Thank you.